So now in our DAQ and I/O modules in LabVIEW tutorial, we will go through the analog input channels and how we can program those in LabVIEW. Here you see an overview of the analog input pins on this USB 6000X DAQ series from NI. Here on the left side you have the analog input pins, and for these DAQ devices you typically have 8 analog output, so-called RSE channels, or you have 4 differential channels. So here you see for the reference single-ended channels you have 8. So here you have analog input 0, 1, 2, 3, 4, 5, 6 and 7. So 8 RSE channels, but if you use the differential channels, then you have only 4. So then you have analog input 0, analog input 1, analog input 2 and analog input channel number 3. Depending on your needs, you can either use the reference single-ended channels or the differential channels. So here is a basic example of the difference between differential and reference single-ended. Here in the example to the left, I'm using the differential wiring. This means if I want to use the channel analog input channel number 0 in a differential wiring type, I need to wire here the black one is minus and then the red one is the plus. If I want to wire it according to the reference single-ended, I can then use this one on my positive wiring, while I can use this ground pinned, or I can of course use one of the other ground pins here as well. But basically the main difference between reference single-ended and differential, here each channel has their own ground or minus connector, while here all the analog input pins has common ground, and that's why it's 8 of the reference single-ended channels, while only 4 of the differential channels, like this. Here you see my hardware setup and wiring, the testing for the analog input example I'm going to create in LabVIEW. So here I'm just wired a battery package on the analog input pin number 0, and here I have used so-called differential wiring. So basically the positive pole from the battery goes to this pin, while the negative pole on the battery, the black one here, goes to this pin on the DAQ device. So let's see how we can create a basic LabVIEW application that are able to read the voltage level on this battery package. So then let's create a basic analog input example in LabVIEW. So then I start by using this DAQ Assistant. I just put it here in my block diagram, and in our case now it's an analog input. So then I need to select acquire signals, and then on analog input, and then voltage. And then as you see here, you have a list of all the available channels from 0 to 7. So I select analog input 0, click finish. And then here you have different options. Minimum, typically you can choose between in the range -10 to 10, but in my case I'm reading a battery. So I select from 0 to 5 voltage. I select here acquisition mode, 1 sample on demand. And here you have this terminal configuration, either differential or reference single-ended. As mentioned, I was wiring this analog input pin number 0 as a differential. So I select it's differential. So these are the settings. Then I just click OK. And wait a few seconds while this DAQ Assistant is getting ready. So now the DAQ Assistant is ready. The next now I just need to create a numeric indicator here on my front panel like this. I can change the name for it, analog input or something, and then I'm using voltage as the unit like this, analog input AE0 like this, and then basically this numeric indicator is wired directly to the DAQ Assistant on the output here like this. So that's the entire program so far. So now I have connected a battery package on the analog input 0 on my DAQ device, and then you see I'm able to read 3.1 voltage. I can of course adjust number of decimals by right clicking on it, select display format, and select a proper number of decimals like this. So I'm reading 3.13 voltage from my battery package. And then next step, typically you of course want to have this in a loop. It's not so important for the battery package of course, but if you connect a sensor or a variable source instead, you typically want to have it inside a while loop. And then you also typically need a stop button for your program, which you wire to the loop condition here in the bottom. So when you click on the stop button, the loop will stop. And then also you need a timer. Here are lots of timers, either this one or this one. You can also use this one, etc. But this is the basic one. And then you just wait number of milliseconds, which you specify here as an input. For instance, 1000 milliseconds like this. And now I can run my application. I get the same value because I'm wiring a battery package here on the input. But if I was reading a signal that was time varying, I would get a different value here. But I can disconnect the battery, and then you will see it will go to 0 like this. So now the battery is disconnected. Now I'm connecting the battery again, and then it will read the proper voltage value from the battery package. Another improvement that you may want to do is to convert to the proper data type, because this blue data type is so-called a dynamic data type, while this one is an ordinary double value. So then typically you may use this built-in function that you find in LabVIEW just by search for it. Convert from dynamic data. So you just select this one and put it here in your block diagram, and then this will pop up, and in our case we will have a single scalar. Click OK, and then just wire the output of data here from the DAQ Assistant to the input here, and the output goes to this double indicator like this. So now you have done a proper conversion from this dynamic data type to a double data type. And of course the values or the result should be the same in our application. So in this basic example, I'm reading the one analog input channel, analog input number 0. So how can you extend the program to read 2 different analog input channels? So let's see how we can do that. Then I need to create another indicator. I just copy it by clicking the control button and drag it like this. So then this one should be analog input number 1, like this. And then I need to do some changes here in my code. I start by dragging it inside this while loop, and then I just the easiest way is to just delete this one and select it once more. And now I want to select the same analog input, voltage, And now I want to have 2 channels, so then I just hold Shift key inside and select number of channels like this. So I now want these 2 channels, analog input 0 and analog input 1. I click finish. Select the same values here from 0 to 5 differential and n samples on demand. Click OK. And now I connect the data output here to this convert from dynamic data. But now I need to do some changes here, because now I have 2 analog input channels. So then I just right click here, select properties. And now I need to select an array instead, so a 1D array of scalars. Click OK. And then, so the output from this function now will be an array. So if I just right click here, create an indicator like this, then you will see the output will be an array like this. And this array will have 2 values. Analog input 0 will be here and analog input 1 will be here. But instead of showing it like this, I want to show first the 0 channel here and the analog input channel number 1 here in this indicator. So then I can use a function from the array palette, namely this index array function, which I can just put here, and then just select the label, and then wire the output to this one as an input here. And then I need to select index, and the first one is 0. And the output here will go to this one, and in order to also connect this one, I just need to drag it, and then here create type 1, and then this output here will go to this one like this. So this picks the first or a 0 element in the array, and this one picks the next element in the array. And then this will become analog input channel number 0, and this will become analog input channel number 1. So now I can run the program. And now analog input channel number 0 is connected to my battery package, showing 3.13 voltage, and this one is not connected to anything, so it shows 0 voltage. So now, assuming I want to put I can put the battery package to this channel instead, and then this would show 3.3 voltage, and then this would show 0 voltage. But basically this is how you use the DAQ Assistant and LabVIEW programming in order to read multiple analog input channels like this. So here you see the alternative solution where I have used the low-level functions instead of the DAQ Assistant. It's almost similar to the analog output example, but here is the analog input example. So then you start by using the DAQmx create task, then DAQmx create virtual channel, and then you here select analog input voltage. Then when you select this one, then you will have a list of the analog input channels. So I have, in this example, select analog input 0, and then you need to start the task, and then you use the DAQmx read, which you find here. And then the output of this one goes to this analog input numeric indicator. And then when you click the stop button, the while loop stops and the logging stops. And then you stop the task, clear the task, and show a basic error message if there are some errors in the system. So let's just run it. And then you see you get the same values here. I get 3.13 voltage. Which is the value from the battery package I have connected to analog input channel number 0. So it's up to you if you want to use the DAQ Assistant or these more low-level functions as part of this DAQmx palette in LabVIEW. Here you see an example where I'm reading from 2 analog input channels, namely analog input 0 and analog input 1, where I have used this low-level functions that you find here. So basically it's similar as the previous example, but here I use two DAQmx create channels. So this one is for channel number 0 and this one is for channel number 1. And then of course I use the start task, read data, and here I use this index array to pick out analog input 0 and analog input 1, and then when the stop button stops, the loop stops, and then you stop and clear the task like this. And it behaves in the same manner where you have the analog input 0 and analog input 1. So this way of program works fine for 2 channels. You can work fine for 3, 4, etc. But then you need to add each of those for each of the channels. So assuming you want to read 8 channels, then you need 8 of those. So then probably it's better to do like this. So here you see an alternative implementation. Here I have used a for loop here, and then you only need one of these DAQmx create virtual channel inside the for loop, and then here on the outside I just create an array of the different channels I want to use. So in that way the application becomes more flexible. I can just extend this one if I need to add more analog input channels. And basically here I just pick out the necessary channels that I want to use, or I can just the output here, I can just use this array directly in my application. So here I will get an array of all the channels that I have specified here in the list of channels. So this is an alternative solution. Yeah, I need to just change it here. It's the analog, it's device number 2, analog input 0 and 1 like this. And then you see this analog input 0 is connected to my battery package. This analog input number 1 isn't connected to anything. Then I can just drag this one to also select analog input number 2 like this, and then run it. And then you also see I will get 0 here because also this channel isn't so far connected to anything. And then I can just easily add more by just dragging here, select the proper input, etc. And just run it, and then I will see the proper values here in this array of values from the analog input channels. So let's go through a more practical examples. I will still use the analog input pin, but here I have connected a temp36 temperature sensor on a breadboard, and then wired this temperature sensor on the analog input pin. Here I have used so-called reference single-ended. So here this red one is going to 5 voltage, this black one goes to ground, and then the signal in the middle here goes to the analog input pin number 0. So here you see the more technical wiring. So this temp36 has 3 pins. This red one goes to 5 voltage, the black one goes to ground, and then the signal pin in the middle goes to the analog input channel number 0. And here I have used so-called reference single-ended wiring. And also the output of this green one, the signal pin, is a voltage value that needs to be converted to a value in degrees Celsius. So then from the data sheet of this temp36 temperature sensor, you will find the relationship between the output voltage that you read here on the analog input 0 pin in this case, and the temperature in degrees Celsius. So it's a linear relationship between the voltage and the temperature in degrees Celsius. And then you end up with this basic formula that gives the conversion from X, in this case, is the voltage, and Y is the temperature in degrees Celsius. So Y equals to 100 multiplied with X minus 50 is the formula that you need to use in your LabVIEW application in order to convert from voltage to the temperature in degrees Celsius. And then let's go to LabVIEW and see how this application looks like. So here you see the LabVIEW application. I already made it. It's very similar to the previous example. I just used the DAQ Assistant. And then, as in the previous example, I just read the output voltage from the DAQ device. And then I use this formula that converts the voltage signal to a temperature in degrees Celsius. So let's just run this application. So the output from the sensor is 0.75 voltage, and then that's correspond to a temperature in degrees Celsius, in this case 24.5. And I can hold my fingertips on the sensor, and then you see the temperature will get higher. If I remove my fingertips, the temperature will drop. It takes some time. Now you see 24, 27.5, 26.5, etc. So this is a very basic example with a practical use of this analog input pin, where I have connected a basic temp36 temperature sensor. I'm able to read the temperature here in my LabVIEW application. Typically, you also want to plot the temperature value. So here I also added a waveform chart. So here I show the current temperature in degrees Celsius, and then here in the chart I show the historical values. So then I can touch my sensor with the fingertips, and then it will go up. When I remove my fingertips, it will go down. So then I see the latest value and the historical values. In addition, I have also included a low-pass filter, which I have created here as a sub-VI. This makes sure that the noise from the signal are removed, and only the smoothed signal from the sensor is shown here in the chart. So here you see the low-pass filter that has been implemented as a sub-VI, and here the formula for the low-pass filter has been implemented in a so-called formula node. And then you have defined inputs on the left side and outputs on the right side. So the input is the measured signal with noise, and then by using this algorithm, the output of this formula will be the measured signal where the noise has been removed. So basically, this is a basic application where you use the DAQ Assistant, this I/O module. You wire a sensor on a breadboard and wire it to the DAQ device, and then you show the value, you plot it, and typically you also need to include a low-pass filter in order to remove noise from the signal. So in this tutorial I showed how to use the analog input pins on the DAQ or I/O modules in LabVIEW, while in other videos in this series I will show how to use the analog output and the digital input and output pins as well. But that's all for now, so thank you and goodbye.